Hello everyone. Good morning everybody. Am I audible to each and everyone? Am I audible to each and everyone? Is audibility absolutely fine? We are live now. This is Mohit here and welcome to the test book. Is audibility absolutely fine? Fine. Good morning Anushri. Okay. So guys, today I am going to discuss the previous year question for KPTCL, that is Karnataka Power Transmission Corporation, and in this paper majority part I will discuss in English language so that all the Karnataka students can able to understand, and some part can I also understand in I also explain in Hindi also. Clear? Good morning Sneha, good morning Pooja. So just like the session first, then we will start our session. Fast. So those students are daily I can explain all the questions, all the things in Hindi only. But today in this examination, I can explain all the things in English. So those students who are from North India, they are not able to understand in English. They can just ask me so that I can explain in Hindi also. Good morning, Sonu. Yes, Naveen, you can watch it. Yes, definitely. All other students who are not aspirant of KPTCL can also watch this lecture. It is very beneficial for you. Good morning, Manisha. Fast. Okay, fine. So let's start our session. Yes. So guys, this is the paper of previous year paper of KPTCL exam. I will just show you the what is the level of the paper. I will just show you the level of the paper. Yes. Yes. Now, the first question, randomly we can discuss the question in a random manner. Random manner we can discuss the question in a random manner. Fine. Okay, sir. Now, this is the first question. In a single phase, in a case of a three-phase induction motor, the rotor power output is 30 kilowatt. Rotor power output is 30 kilowatt. If the slip during operation is 4%, then the rotor copper loss is. So guys, rotor copper loss are PCU should be equals to S into P2. What is P2? Guys, P2 is your rotor power output. Clear? That is also rotor power input. P2 is your rotor power input. Clear? Fine. But in this case, he has given you that is 30 kilowatt, that is rotor power output. So as rotor power output is mechanical power, so mechanical power should be equals to P2 into 1 minus S. Fine. Okay, sir. So on the basis of these two formula, we can able to solve the rotor copper losses. Rotor copper losses are SP2 and mechanical power output, that is rotor power output, is P2 into 1 minus S. The value of slip is 4%, so the mechanical power should be equals to rotor power input into 1 minus of 0.04. That is what is the value of P2 here? So what is the value of P2? So guys, the value of P2 should become equals to, here the mechanical power is 30 kilowatt. Here the mechanical power is 30 kilowatt. So 30 divided by 0.96. Clear? 30 divided by 0.96, that is 31.25 kilowatt. This is your mechanical power output. Now put this power into S, that is 0.04, that is 1.25. So rotor copper losses are 1.25 kilowatt, that is 1250, that is 1250 watts. So this is a very simple question, guys. This is a very simple question on the basis of three-phase induction motor. Fine. Okay, sir. Now we have to go with next question. Next question, just like this. Yes. The slip of induction motor normally not depends upon. So guys, can you able to explain it? Can you able to give the answer for this question? The slip of induction motor does not depends upon. Fast. Induction motor slip does not depend upon. Fast. The slip of induction motor does not depends upon. Fast. Sharp synchronous speed. Yes, it depends upon synchronous speed. Rotor speed, yes, it depends upon the rotor speed. Shaft torque or core loss component. Shaft torque or core loss component. So definitely guys, the slip of induction motor does not depend upon core loss component. Does not depend upon core loss component. Clear? Fine sir, fine. What is electromagnetic radiation with maximum wavelength? What is electromagnetic radiation with maximum wavelength? Jaldi, fast, fast, fast. Fast, fast guys. We have to complete 20 questions today. Fast. What is electromagnetic radiation with maximum wavelength? Electromagnetic radiation with maximum wavelength. So guys, the electromagnetic radiation with maximum wavelength are always radio waves. They are always radio waves. They always are radio waves. Fine? Okay sir, fine sir. Now, fine sir, fine, fine. Now, this question. We have to complete 20 questions today guys. How many questions? 20 questions. The voltage applied to a circuit is 100 root 2 cos 100 pi t, and the circuit takes a current of 10 root 2 sin 120 pi t plus pi by 4. Taking the voltage as the reference phasor, the phasor representation of the current is. So guys, first thing we have to take the voltage is 100 root 2 cos 100 pi t, and the current should become equals to 10 root 2 like this. Clear? Fine sir. Okay, so current, your current should become, this is the voltage reference, this is your voltage reference, and your current is at a leading of pi by 4. Your current should be a leading at pi by 4. This is your current which is leading with a pi by 4. Fine? Yes sir. This is the current which is leading with pi by 4. This is pi by 4. What is the value of pi by 4 in degree? The value of pi by 4 should be in degrees 45 degree. Fine? Okay sir. So now he is asking, taking the voltage as the reference phasor, the phasor representation of the current. So guys, the phasor representation of the current should become equals to, that is 10 root 2. So take it as the RMS value, that is this 10 root 2 is maximum value. So take the RMS value, that is 10 root 2 divided by 10 root 2 divided by root 2, and take the angle also, that is plus pi by 4. Why we are taking the plus pi by 4? Because it is leading in nature. If the current should be lagging in nature, that is there, it is if there is a minus pi by 4, we can take it as a minus pi by 4. So guys, this cancel, the current should be equals to 10 at an angle of pi by 4. So guys, 10 at an angle of pi by 4 is there in option, so we can check it. Otherwise we leave this question. Yes, 10 pi by 4 is in the option. Finally, clear? Okay. Now move to next questions. Move to next question. Fast, 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 fast. Fast. So we have to deal only the technical questions of electrical engineering. Okay? If the periodic current 2 plus sine omega t ampere is applied to a 1 ohm resistor, then the power dissipated by the resistor will be. Now again we have to calculate this question. If the periodic current 2 plus 6 sine omega t is applied to a 1 ohm resistor, then the power dissipated by the resistor will be. Then the power dissipated by the resistor will be. Then the power dissipated by the resistor will be. Fast. Fast, fast. So guys, the first thing is the power dissipated by the resistor should be equals to I RMS square into R. Fine? Yes sir. Now what is the value of I RMS? So the value of I RMS should be, under root of 2 square plus 6 by root 2 whole square. 6 by root 2 whole square. Now what is the value of I RMS? What is the value of I RMS? That is 4 upon 36 divided by 2, that is 4 upon 18 under root of 22. So 22 under root of 22. So guys, the IRMS should become equals to under root of 22. Now under root of 22 whole square should be value of register 1, then the power should become equals to that is 22 watt. The value of power should be 22 watt. Clear hai? That is a very simple question. That is very simple question. Now we have to come with this question. Images not clear? No Shankar, images are already clear. The images are clear. Which law explains? Now we have to calculate this. Which law directly explains the law of conservation of mass? Law of conservation of mass, not the law of conservation of charge. Which law explains the law of conservation of mass? This question can comes in the science also, no doubt, but we can take it as a basic electrical. Fast. Fast. Guys, can we take law of conservation of mass as a Kirchhoff's law? No. Kirchhoff's law is based on the law of conservation of energy or law of conservation of charge. Clear? Law of conservation of charge. So go for other options. Avogadro's law? No. Avogadro's no law nahi. No. So guys, I will give you the assignment for this question today. This is the physics question. This is not the right answer. These two are the right answer. Clear? Out of these two are the right answer. You have to go for that. Clear? So today you can search it on internet. Just which of the following is the law of conservation of mass? Directly explain the law of conservation of mass. Fine? Okay, sir. That is not a pure electrical question. That's why I will give to you. Now, in an alternator, the armature reaction is represented in the equivalent circuit diagram by. So guys, I will draw the equivalent circuit of armature, equivalent circuit of synchronous machine. That is resistance, that is reactance, Fine. Okay. This is RA. This is JXS. Guys, this is your EF. And this is your VT, and if it is a generator, then this is the armature current. So guys, the thing is, in this axis there are two components, that is X. In this XA there are two components, synchronous reactance, there are two components. One is armature reactance, that is called XA, and another one is leakage reactance, that is XAL. So he is asking you, what is the armature reaction? How can we represent the armature reaction? That is called XA. So this is reactance. This is modeled by the value of what? Reactance. This is modeled by reactance. This should be modeled by reactance. Fine, sir. Fine. Yes, Ajay, other students are eligible, but you have to be cleared the language test of in Kannada language. That is of 150 marks. Fast. Can we go for next question? Yes, sir. So guys, questions are not so tough. Questions are very simple. You have to just understand the basics. Questions are very simple. You have to just understand the basics. Actually, this paper is mix-up type, so I have to search the questions which are from electrical engineering. Okay, fine. Now, the average power delivered by an impedance, we have to deal with this question. The average power delivered to an impedance 4 minus 3j by a current 5 cos 100 pi t plus 100 degree. Fast, calculate this. The average power delivered. The average power delivered. Yes, Sonu, sure. I will provide this PDF to Telegram channel today. By today. Fast, guys, fast. Fast, fast. Fast, calculate this. So guys, the thing is, this is your current. Okay. So your current should become equals to what? That is maximum. What is the value of RMS current? That is maximum divided by root 2. That is 5 by root 2. This is your current. Fine. Now the average power is always delivered only in the resistive component, not in the reactive component. So guys, the power should become equals to, the average power should become equals to average power should become equals to Im by root 2 ka whole square into 4. That is what? 50 watt. That is your 50 watt. Fine. Simple question. That is your 50 watt. Now we have to go for this question. In an ideal transformer, the no load current I0. In an ideal transformer, the no load current I0. In an ideal transformer, the no load current I0 will be what? Fast. So guys, can we draw the phasor diagram of ideal transformer? Yes, sir. So guys, this is your flux. This is your flux. Fine. Yes, sure, sir. This is your flux. That is called phi m. The value of induced EMF is always in the lagging condition. The value of induced EMF is always in the lagging condition. Now, the magnetizing current is always here. There is no extra anything here. There is no another component is here in this phasor diagram. So in the ideal transformer, the no load current I0 lead the applied voltage. Okay, fine. Now we also draw the applied voltage. This is your applied voltage. This is the phasor diagram for, this is the phasor diagram for an ideal transformer. Okay, fine. Lead the applied voltage by 90 degree in phase with the applied voltage, lag the applied voltage by 90 degree. So guys, this is your applied voltage and this is your current. So it is lag by 90 degree. It always lag by 90 degree, but it should lead by what? It should lag by supply voltage, but it should lead by induced EMF. It should lead by induced EMF. Fine, fine, sir. Fine, fine, fine. Now, again the question of synchronous generator. This is a very good question. That is in the form of statements. Fine. Consider the following statement given as the reason of application. Consider the following statement given as a reason of application of short pitch coil compared to full pitch coil in a stator of a synchronous generator. So guys, this is the question of advantages of or the points of short pitch winding. So if your winding is short pitch, if your winding is short pitch compared to full pitch, then just give me the answer. Improve sinusoidal waveform of induced EMF. Distortion harmonics are significantly reduced. It increases overall induced EMF. Fast. So guys, always think the short pitch winding is used in the synchronous generator or in the alternator to reduce the harmonics, to eliminate the harmonics. So this is correct answer. If the harmonics are eliminated, then your waveform also improved. It increases overall all induced EMF. No, not overall. It reduces the EMF. So 1 and 2 is correct only. 1 and 2 is correct only. So this is again a simple question, guys. Again a simple question. Fine. Now, this is the question comes from measurement. The power in a DC circuit, a power in a DC circuit is measured by measuring the current through a resistor. The current is measured with an accuracy of 1.5% and the tolerance band of the resistor is 0.05%. That is the error. Clear? If the error are limiting or guaranteed, then the accuracy with which power is measured. Fine. Calculate it. Calculate it, guys. Calculate it. Calculate it. The power in a DC circuit is measured by measuring the current through the resistor. So guys, the power should be equals to what? That is I square into R. Fine. So we can also calculate it as a I into R. So whenever the quantities are in multiplying nature, then the percentage error is always added. So what is the percentage error in current? That is 1.5%. And what is the percentage error in resistance? That is 0.5%. So guys, overall percentage error in the power should become equals to 1.5 plus 1.5 plus 0.5, that is 3.5%. The correct answer should be 3.5%. This is a very simple question. Already I discussed in my some of the lectures. Clear? Already discussed, भाई. Already discussed. यस नरू, तो इस टाइम क्लास नहीं रहता, बट बेटा इस टाइम जो क्लास रह रहा है वो केपीटीसीएल के स्टूडेंट्स के लिए है ना, मोस्टली केपीटीसीएल के स्टूडेंट्स के लिए, उनके लिए प्रीवियस ईयर पेपर करवा रहा हूँ, ठीक है, ध्यान रख. द सर्किट टर्न ऑफ टाइम ऑफ एन एससीआर इज डिफाइंड एज द टाइम. Circuit turn of time of an SCR is defined as the time. Fast. What is the circuit turn of time? Fast. Fast, guys, fast. What is circuit turn of time? Fast, fast, fast. Yes, 1 बजे वाला है. Circuit turn of time of an SCR is defined as the time required for the SCR current to become zero, for which the SCR is reverse biased to reduce its current voltage, taking the SCR to turn off, for the which the SCR is reverse biased by the commutation circuit. So guys, the thing is the circuit turn of time, clear it, and a circuit turn of time, that is for which the SCR is reverse biased, really fast. So the SCR should be reverse biased to reduce its current below the holding current. So if the SCR current goes below the holding current, that means what? That means what? All the charge carriers can recover. All the charge carriers can recover to their. All the charge carriers can recover to their position, and SCR is treated as off. Now the guys, question number 49. Again, the question is of measurement. The bridge most suited for the measurement of a 4-terminal resistor in the range of 0.001 to 0.1. Fast. The bridge most suitable for the measurement of 4-terminal resistance in the range. That is, this is the range of, guys, low resistance. And low resistance can be represented by 4-terminal, not only 2-terminal. That is 4-terminal. This is called low resistance, and it can be measured by your Kelvin's double bridge. The value of low resistance is always less than 1 ohm. Fine. Okay, sir. Which of the following material are antiferromagnetic material? Antiferro. Which of the following material are antiferro? Fast. So guys, here all the 3 materials are antiferro in nature. That is ferrous oxide, manganese oxide and chromium oxide. Whenever we go for oxidation, Antiferro means what? Anushri, there are so many types of magnetic material, like a paramagnetic material, that are diamagnetic material, ferromagnetic material, ferrimagnetic, and antiferromagnetic material. All the magnetic materials can have different types of property. Like diamagnetic material are those materials which are also called as non-magnetic material. Fine, sir. Ferromagnetic material are those materials which allow very large amount of magnetic field lines through it, that is iron, cobalt, and nickel. They are strongly magnetized material. Paramagnetic are very less strong magnetized. So all the things which decides the ferromagnetic, antiferro, and different types of material, these all the parameters are basis on the dipole, and also and a basis on dipole and susceptibility. Fine. Okay, sir. Now this question आपको बताना है ना? You have to give the answer. This is a statement, this is the reason, this is assertion, this is the reason. You have to take it. Clear? And these are the four options. Transformer oil works as an insulating material as well as cooling agent. Definitely it is the right answer. Definitely it is the right answer. Now the reason of transformer oil as an insulating and coolant is this: the transformer has high dielectric strength, okay, so that's why it is act as an insulating material, and low viscosity, okay, that's why it also act as a cooling agent. That means both A and R are correct. Both A and R are correct, and also it is the correct, sorry, both A and R are correct, and also it is the correct explanation of A. Why it is correct explanation? Because guys, if you are using a high dielectric strength oil, that means it can be used as an insulating material, and if you want as a cooling agent, then it should have a low viscosity. It should have a low viscosity. Fine. Okay, sir. Fine, sir. Fine, sir. Now, next question. In a double cage three-phase induction motor, the inner cage has a high resistance as compared to outer cage. The inner cage has high resistance and high inductance as compared to outer cage. The inner cage has low resistance and higher inductance as compared to the outer cage. Fast. So guys, in a double cage squirrel induction motor, double squirrel cage induction motor, always resistance of outer is greater than resistance of inner. Always resistance of outer cage is always resistance of inner, so the inner resistance is always low. And in double cage, just remember guys, in double cage induction motor, we are always going with we always start our motor with the outer cage, so that we get a very high starting torque. After that, when motor comes to its 60 to 70%, that the motor will run with the inner cage, because it have a low resistance, so that the I square R losses will be reduced in the performance, and motor efficiency will be increases, heating also reduces. Fine, sir. Now, just solve this question. Two identical coupled inductors are connected in series. The measured inductance of two possible series connection are 380 and 240. Their mutual inductance will be. So guys, if two inductors are connected in series, so just simple. Fine. This is L1 plus L2 plus 2M. This is the condition. That means L1 plus L2 plus 2M should be equals to what? 380. Similarly, another situation is what? Sir, another situation that is L1 plus L2 minus of 2M, that is what? L1 plus L2 minus 2M, that is your 240. Now he is asking to you, what is the value of this mutual inductance? So guys, just equation number 1, equation 2, these are the two equation 1 and equation 2, these are the two equation. Clear? Just subtract equation 1 from equation 2, so that subtract equation 1 minus 2, that is this to be cancelled. 4M should be equals to 140. 4M should be equals to what? 140, I think. Yeah. 4M should be equals to what? 140. Right? Yes. The correct answer of M should be 35 microhenry. The correct answer should be 35 microhenry. Again this is the simple question, guys. Again this is the simple question. Next. So we can solve one more question. Among the following, which one of the bridge method is commonly used for finding mutual inductance? So guys, mutual inductance can be found out by clear mutual Wales bridge, guys, frequency, sharing bridge, capacitance, de-Sauty, capacitance. But mutual inductance can be found by Heaviside Campbell bridge, and I also give some other names of mutual inductance: Heaviside Campbell bridge, Head-Wheeler bridge, Heaviside bridge, and also Carey-Foster bridge. There are 5 bridges which are used for calculation of mutual inductance. This is Heaviside Campbell first, that is your Campbell bridge, that is Head-Wheeler bridge, that is Carey-Foster bridge, and also Heaviside bridge. Fine? Yes, sir. Okay. So guys, today I will show you the level of the paper of KPTCL exam. You can take it as a reference. All those aspirants who are from Karnataka, they can take it as a reference. This is the previous year question of 2016 of KPTCL. So you can take it as a reference and prepare like that way. Prepare like that way. They are very good question. They are above SSC JEE level. First I will tell you they are above SSC JEE level. Fine. Okay, sir. Fine. Now I will give you some information also regarding that. So guys, we are preparing for KPTCL exam. We are already launched one batch for that. That is for Electrical JEE Live Coaching Batch 4. Electrical JEE Live Coaching Batch 4. Guys, this batch is started from 15th of Feb and end with the June. But the batch is almost with the bilingual language, that is English and Hindi. The teachers can explain you entire topic in Hindi and notes will be prepared in English. Guys, this batch is of validity of 1 year, but this batch is completed in the June. The cost of this batch is 7,999 rupees, and if you are using this code that is called Mohit K, so just go for the Testbook website or Testbook application and search Electrical JEE Live Coaching Batch 4, and before enrolling, just use this coupon code that is called Mohit K, so you get instant 37% discount and you get this batch only in 3,400 rupees. Guys, this batch contains 160 plus live classes, 320 plus hours syllabus, 4,000 plus practice question. Similarly, guys, after that, join my Telegram channel. That is like this. Clear? So you have to just remember the code that is Mohit K. So go join my Telegram channel also, so that you can connect it with me and you can get all classes access, all PDF access, and also if there is any problem, you can just directly interact with me. I can comfortable in English and Hindi both, so don't worry. That is the name of the Telegram channel is Mohit Kasanya Sir Testbook. So just search, get my pic, and also join this Telegram channel. Fine, okay, sir. And those students who are already prepared before KPTCL exam in some other exams also, they can join the test series, India's biggest test series, that is called Testbook Pass. So guys, just search on the Google, that is Testbook Pass, and it can provide you 34,000 plus mock test, 474 covering 470 plus exam using this code that is called mock pass. So if you want to prepare for KPTCL exam and you already studied somewhere else, you can just go for Testbook Pass for your test. Attempt so many number of tests. There are more than 800 tests for you. Attempt so many tests and also get improve your accuracy and also improve your speed. So guys, go for Testbook Pass, search and use this code that is called mock pass for test series and Mohit K for course. After using that mock pass, you get instant 15% discount, and for 1 year it is only 300 rupees, and for 1 year it is only 300 rupees, guys. Fine. Okay, sir. Okay, sir. Okay, fine. So guys, thank you very much for today's session. Guys. Yes. So guys, we will meet in the next session. So thank you very much.